Hi, my name is Yasmin Lilja-Rosgaardsdottir, and I'm gonna present experiment 2 about superposition. Right, so now I'm gonna do the theoretical part, and we want to calculate the node at A voltage and the current going through resistance 4. So what we want to start by, because this is the circuit that has only 3.3 volts, we removed the 5 volts. So we start by calculating the total resistance. So we do that by first taking these two in parallel and them who are in series with R4 and them parallel with R3, and the rest is in series with R1, and we get the total resistance, that is 12,043.12 ohms. So then we want to find the total current going through the circuit, and we do that by dividing E1 with the total resistance, and that will be 2.744, and that's the current here. And then we can find the voltage at node A by subtracting E1 from the total current times R1, and that will be 2 volts. We want to keep that number. So next we want to find the current going here through R4. So we do that by first finding the current that is going through resistance 3. So we just put it like this, and that will be VA divided by R3, and we get this current right here. So then finally we find current going through resistance 4, and then we subtract the total current minus the current going through R3, and then we get this current right here, and we also want to keep that number here. Alright, so now we have these two numbers, and we want to go and calculate here the voltage at node A again and current through resistance 4, but now we have 5 volts but removed 3.3 volts, so exactly the opposite. So we find again the total resistance, and that's again here, these are in parallel, and they in series with this, and then parallel again, and then in series. And from that we have 25,197.28 ohms. No, wait, that's wrong. And then we get the total resistance, which is 21,087.79 ohms. So now we want to find again the total current going through. So that's E2 divided by the total resistance. And we get from that 2.37 times 10 in the power of -4. And then we can find the voltage at node B. And that will be E2 minus total current times R2. And that will be 3.39 volts. But that's not the node that we want. We want it at node A. So to find that, or it's actually easier to find the current first at R4. So here we find the current going through so now we want to find the current, which is going here through R5. So we do it like that. It's voltage at node B divided by resistance 5, and that is this current. And then from that we can find the current, it's going through resistance 4, which is the current going through, or the total, and minus the current going through R5. And there we will get 1.34 times 10 amperes. And that's, again, a number we want to keep. So, finally, we find the voltage at node A, which is node B, minus the current going through R4 times R4. And that will be 0.442 ohms. And that's, again, a number we want to keep. So now we've got all these numbers, and to find the total VA, or voltage at node A, we need to put together VA in the circuit with only E1 plus VA from the circuit only with E2. So if we just check the number here, that is 2 volts. So we get 2 volts plus 0.442, and that will be 2.442 volts. And then also the current going R4, we do the same thing. Take from both circuits, and then we get this number here. and that will be 2.08. There. So then we have the answers. And so we can also calculate the power in resistance 4 by using the current that's going through R4. We do that by finding the voltage drop. Which is right here. And that's 4.576 volts. And then we can find the power. Which is the voltage drop times current going through resistance 4, which would get to be this number here. Okay, so now I'll be starting the experimental part. And we're gonna set up the circuit with E1 or 3.3 volts alone, so with 5 volts removed. So we have the main breadboard here. I'm just going to take the 3.3 volts, looks like this, the regulator, and put it in the breadboard like this. And then I'm just going to put the battery here. We have red and black wire. And put it here, the red to the red and black to the minus. So then I want to connect the input of the regulator to the plus. So the input of this regulator is to the left, or like here. So I'll just put this here in and connect it to the plus. Now we will connect, just take a black wire and connect the ground of the regulator to the minus. So the ground is the exact opposite side. Put here and here. And so the only one left is the output, which will be connected to the circuit. So then we'll just start by taking our first resistance, and that will be 4.7 kilo ohms, which is right here. And so we'll connect that to the output here, and just anywhere the other end. And so according to the circuit, the one that's connected to that one is 10 kilo ohms, which is this one right here, if you can see. Yep. And that one should be connected to the ground as well. So wait, if we twist it a bit here, should be connected. In series to the resistance, and then to the ground as well. It doesn't have to be next to it, but okay, I think we got it. So then we got resistance 4, which is 22 ohms, which is this one right here, as you can see here. And that one is also connected in series to those two resistances. So we just want to connect that one right here next to it, and then just anywhere else. Like that. As you can see, they hear 3. Right? And then to this one, we should connect the 33 kilo ohm, this one here, and connect that one to the ground, which we'll just do later. So maybe put this one here, connect it to that one, just anywhere. And then lastly, take the 6.8 ohms, kilo ohms, connect that one also next to them here, and also to the ground. So as you can see, because anything here is not connected to here, so these two are not connected to the ground. So we will have to take an extra jumper wire here. We'll need to connect these to the ground. So we'll just put it here next to it and put it here and the minus right here. So that's this circuit, and then we just need to measure it. Okay, so now I've got the digital multimeter and connected these to measure the voltage at node A. So node A is right here. And so to measure that, we're going to need another jumper wire and connect it to the ground. So what we want to do then, so you can see here, and I put it to 20 volts because I think it's going to be a bit more than 2 volts. Just going to touch it here. And then to the resistance 4, touch it there. And as you can see, we're getting around 2 volts. Or like 1.97, which is around 2 volts. And then we're gonna measure the current going through resistance 4. What we want to do then is take resistance 4 and put it somewhere else, not in series. And then we want to take a jumper wire, put it in series where it was, and then we want another jumper wire. Just gonna get one here. Right here, and put it next to where we moved it. And then of course we need to change this. I'm just gonna put it to 2 milliamps and just put it to, what I have here, to the jumper wires, and then here. And as you can see, we're then getting 0.071 milliamperes. Now we want to make the other circuit, which is when the 3.3 volts regulator is removed and the 5 volts is put in. So what we want to do is just remove this one, take it out, and then add this one, but this one is actually over here, so we might need to move these a bit. So if we just put this volt regulator right over here, and what we want to start by doing is just, you know, put the red jumper wire, which will be the input. So the input is right over here, all the way here, and then put in the plus. And then we want to take this black one, which will be connected to the ground, which is here in the middle of the regulator, put it to the minus, and yeah, these one are the same, the battery. And then, you know, the circuit is kind of the same, maybe just move these two a bit here to the left. I think this is okay. And what you want to notice is, so before these were not in series, like here below, but because we removed the 3.3 regulator, they are now both connected to the ground, so they need to be in series right here. Okay, so all right, but otherwise it's just the same. Just take the 33 kilo ohm right here and kind of connected the same, except it's connected to the ground. So we put it in series with this one, and then to the ground, just in the middle of the regulator. But then we want to take this guy, 6.8 kilo ohms, also put it in series, but the end should be to the output. So if we could just right there, should be fine. So as you can see, as earlier, these guys aren't connected to anything and they want to be to the ground. So then we just take jumper wire we used earlier and connect them to the minus right here. And that is the circuit, second circuit, and we measure them. Okay, so now we're gonna measure again the voltage at node A. So again, just take another jumper wire and connect it to the ground. And here, just gonna measure here. And then we're getting around 0.433 volts. And then if we want to measure the current going through R4, which is this one right here, we're just gonna again put it somewhere else, put a jumper wire where it was, and a new jumper wire where it is. Change the multimeter to 2 milliamps. And just measure right here. And as you can see, it's about 0.137 milliamps. Okay, so finally we want to have both the 5-volt regulator and the 3-volt. So how I will do that, just gonna remove here. I'm gonna put this one back. And then we want, let's just say this one goes to the input plus, then this one goes to the ground, to the other end, here, and then we want to put, so this one is at the output, but we want to move this guy right here to the ground. So the 10 kilo ohms, we want to move this one back. It's in series, and that should be about it. This is all right, yeah. So then we just put this back here. So that's the whole circuit. Okay, so now I will start the simulation part. I'm gonna start by drawing the circuit with E1 alone, which is 3.3 volts. Then add the components here. And the voltage source, or a battery, it's the same. So here, then we're gonna put the values. So this one is 3.3 volts. This one is 4.7 kilo ohms. Here we got 6.8 kilo ohms, and then 10 kilo ohms, 22 kilo ohms, and lastly 33. So here we got the circuit, and we're gonna put ground. Go here, ground, and put it here. And then we're gonna add a command so we can run the circuit. Just put here. Just put it around here somewhere. And then we're just gonna run the circuit to measure VA. So here, and okay, So in here we'll get the values. And now here is point VA or node A. We just press on it and here we get the measurement. So we just click here and it's 2 volts, about 2 volts. And then to get the current going through resistance 4, we just press on the resistance. So here, and that's the blue line here, and just press on that, and that's, so the minus here is just the direction, but it's 72 microamperes. Alright, so that's for the first circuit, or like with A1 alone. So now we'll just remove this one. Right here, cut this one out. Connect it, and then add this right here. And so that one gets the value 5 volts. And so now we'll just do the same thing. Just run. And we will measure the node A. And there we get 429 millivolts. And then here, resistance for the current. And that's 134 microamperes. And so now we'll have the whole circuit, because this was, we're calculating it with superposition. So we'll just add another one right here. Same as earlier, 3.3. And then we measure it. And we get here, the voltage at node A is 2.44 volts. And so if you add the one from the first circuit to the second circuit, you'll get this number. And so the same for here, the current. And then we get 6.1 microamperes, which is also, if you add the current from the first circuit and the second circuit, then you'll get this number, which tells us that this is accurate, that you can just add them together. So finally, I have put all the values up in this table, the theoretical part, experimental, and simulation. And as you can see, all these values are similar between the parts. So here 2 volts, 2 volts, 2 volts, 0.4, 0.4, 0.4. So what we were trying to see in this experiment was whether we can use superposition to find E and E2 by doing E1 plus E2. So as you can see, these two are the same, and these two are quite similar, and these two as well. So that tells us that we can use superposition to find the voltage at VA and the current through resistance 4 by putting E1 and E2 together instead of just finding with maybe mesh analysis or node analysis. But however, I put here, I calculated the power in resistance 4, and there I was testing if we can also use superposition. But as you can see, this number and this number are not the same. So that tells us that we cannot use superposition to find the power.